All right, today we're pulling back the curtain on computer networks. We're going to explore the incredible hidden infrastructure that powers pretty much everything in our digital lives. I mean, really think about it. You click on something and bam, in less than a second, information from the other side of the planet is right there on your screen. It feels like magic, doesn't it? Well, it's not magic, but it's one of the most amazing systems humans have ever built. So how on earth does it work? Well, the secret is a whole hidden world of devices, routers, switches, all that good stuff, all linked up by wires and invisible waves, and they're all speaking the same digital language. In this explainer, we're going to map out this world together, one piece at a time. So here's our game plan. We'll start with how networks shape our everyday lives. Then we'll get into the actual rules that let all our gadgets talk to each other. After that, we'll check out the different blueprints for building a network. We'll follow a tiny piece of data on its wild journey. And finally, we'll look at the actual physical stuff that makes it all happen. Okay, first things first. Let's just take a moment to appreciate how totally woven into our lives these networks really are. I mean, they're the engine behind basically all the ways we communicate now. The instant messages we fire off, the social media feeds we scroll through, the tools we use to work together from anywhere, all of it depends on this instant global connection. It has completely changed how we interact with each other. And just look at learning. We used to be limited to physical books and classrooms. Now, we've got online courses with video, audio, interactive data, all available to anyone, anytime, from literally anywhere. Networks have just smashed the old geographical barriers to getting an education. So you've got to wonder, how do all these different devices, made by tons of different companies, all manage to understand each other? Well, that brings us to the rules of the road. The secret sauce is something called a protocol. You can think of it like a shared language, or maybe a set of etiquette rules for devices. It's a strict agreement on how data needs to be packaged and sent, making sure that communication goes off without a hitch. And a protocol isn't just one simple rule. It's the whole rule book. It defines exactly how a message should look, it sets the size of the data chunks being sent, it manages the timing, like who talks when, and it even controls how information gets translated into ones and zeros. When you boil it all down, network communication is just like any other kind of communication. You need a source, that's the sender. You need a destination, the receiver. And you need a channel, that's the path the message takes to get there. It's a universal concept. Okay, so we've got the rules down. Now let's talk about the blueprints. What do these networks actually look like when you zoom out and see them at different scales? Generally, we talk about networks in three main sizes. On the small end, you have the LAN, the local area network. That's your Wi-Fi at home or the network in your office. On the massive end, you have the WAN, the wide area network, which connects different LANs across huge distances. The internet, that's the ultimate WAN. But right in the middle, there's something called a MAN, or a Metropolitan Area Network. This is super important. It's bigger than a LAN, but smaller than a WAN. Think of a network that connects all the buildings on a huge university campus, or one that links up a company's different offices across an entire city. It's the network for a whole metropolitan area, bridging that gap between local and global. And these networks, whether they're LANs, MANs, or WANs, can be built with physical cables for a super stable connection, or they can use radio waves for that wireless freedom we all love. But here's the key thing to remember. It's not one versus the other. They're a team. Your Wi-Fi is almost certainly plugged into a wired network somewhere to connect you to the rest of the world. So, how are all the devices on a network actually laid out? We call that the topology. A couple of classic examples are the bus topology, where every device hooks into one main cable. It's simple, but hey, if that one cable fails, the whole network goes dark. Then there's the ring topology, where every device is connected in a circle and messages get passed around from one to the next. Every layout has its own pros and cons when it comes to cost, speed, and how reliable it is. Okay, we've seen the big picture. Now for the really cool part. Let's zoom way in and follow one tiny piece of your data as it goes on this incredible journey across the network. I mean, with billions, literally billions of devices out there, how does your message find its way to the exact right person without getting lost in that massive chaotic maze? The solution is actually pretty genius. It's all about layers. To handle all that complexity, networks break down the huge job of communication into a stack of smaller, manageable tasks. Each layer has one specific job to do, and it only has to worry about the layer directly above and below it. So picture this. As your data leaves your computer, it travels down this stack. It starts at the top, the application layer. That's your web browser. Then the transport layer makes sure it gets to the right app on the other end. The network layer's job is to figure out the best path across the entire internet. Then the data link layer gets it across the local connection, like from your laptop to your router. And finally, at the bottom, the physical layer turns it all into electricity or light to send it on its way. Now, that 5-layer model is great for understanding the theory, but in the real world, the internet we use every day actually runs on a simpler 4-layer model called TCP/IP. And why is it simpler? Well, it's all about practicality. It combines a few of those layers because when you're actually building the hardware and software, it's just a more efficient way to get the job done. And that brings us to our final stop on this tour, that bottom layer, the physical one, the actual, tangible stuff that carries our digital world.
First up, coaxial cable. You've definitely seen this before. It's the kind of cable that brings you cable TV or internet. It's got a copper wire in the middle, wrapped in insulation, and a metal shield. That shield is super important for protecting the signal from outside noise. And then we have fiber optic cable. This stuff is the absolute backbone of the modern internet, and it is just mind-blowing. It sends data not with electricity, but with tiny pulses of light shooting down a strand of glass that's thinner than a human hair. Just think about that. Your information is literally moving at the speed of light. That's what makes those incredible speeds and continent-crossing connections possible.
And of course, we can't forget wireless. In this case, our data becomes electromagnetic waves zipping through the air. And depending on the signal, these waves do different things. Some hug the ground, others bounce off the atmosphere to cross oceans, and some travel in a straight line, which is exactly how your Wi-Fi router talks to your phone and how we talk to satellites way up in space. So there you have it, from a simple click on your screen, down through all those layers of rules, across different network blueprints, and through physical wires or invisible waves to its destination. Every single thing you do online kicks off this incredibly complex but beautiful digital dance. The only question left is, what part of this hidden world are you going to dive into next?